Okay, we pick up with example 4. Yesterday we found the area bounded between two curves. Today we look at y equals x to the fourth and y equals 2x squared minus 1. The first requirement is that you are going to be able to visualize these graphs. What does x to the fourth look like? Yeah, it basically looks like a parabola, right? Except it gets steeper on the sides, right? Well, y equals 2x squared minus 1. It's also a parabola but down one. And this is confusing. I mean, it's like, how do I draw it? Do I draw it so it touches this parabola once? Do I touch it so that do I draw it so it doesn't touch at all? Does it cross twice? So I'm going to draw it 3 different ways, like that, where it kind of just looks like maybe it touches once, or maybe it goes through in 2 spots, or maybe it comes up and it never crosses through those spots. Pretty tough to tell, huh? In fact, I wonder if they intersect at all. How would I determine if they intersect at all? Set them equal to each other. X to the fourth is equal to 2x squared minus 1. X to the fourth minus 2x squared plus 1 is equal to 0. Fortunately, you are excellent at factoring. How does x to the fourth minus 2x squared plus 1 factor? X squared minus 1 times x squared minus 1. Does that factor? To plus and minus 1 and to plus and minus 1. Agreed? So would you say that negative 1 is a double root and positive 1 is a double root? We have double roots, it means that they touch tangent, correct? And that's going to be the case in this situation. So I apologize for the kind of poor representation I have for a graph. I wish it was better, but it's not. So this coordinate has a value of 1 for x. What's the value for y? And you get 1. This also has an x value of negative 1. What's the y value? 1. I'm going to show you now something that can save time for you. Some people won't pick up on this, and I apologize. You don't have to use it, but without a doubt, I use it every time, and it's a huge time saver. Got it? As I set up the integral, the top, in this case, is x to the fourth. The bottom is 2x squared minus 1. We all agree? So therefore, the integral becomes from negative 1 to 1 of x to the fourth minus 2x squared plus 1 dx. Is everybody good? Because the red one is the 2x squared minus 1. We good? Here's the shortcut. Although my drawing doesn't depict it very well, do you guys agree that the area on the right-hand side should be the same as the area on the left-hand side? It should be. So therefore, I can rewrite this integral and make it easier on myself. Anybody know? Very good. I'm going to go from 0 to 1 to just find the area on the right-hand side of x to the fourth minus 2x squared plus 1 dx, and I will double it. You see that little trick? You sure can. However, believe it or not, some students respond poorly to negative numbers and even make mistakes when they plug them in. I like plugging in 0 because in this situation, when I plug in 0, I'm just going to get 0. you plug in 0 right now, you get 1, but when we take the antiderivative, we'll get 0. I'm much less likely to make a mistake. And I like avoiding mistakes because I make so many of them. And when I do, people are relentless in reminding me that I made them. So here we go. X to the 5th over 5 minus 2x cubed over 3 minus x. I'm going to multiply that by 2. Whoop. Plus x. Thank you. Thank you, Riley. Nothing wrong with that. Well, yeah, I'm going to do the integral, and after I do the integral, then I'm going to multiply by 2. Just trying to follow the order of operations. No, I'm... Oh, jeez. try to, oh my gosh. Here we go. 2 times. I plug in the 1. I get 1/5. I'm going to convert it to 15ths. So I've got 3/15. I plug in 1 here. I've got 2/3 or 10/15. And if I plug in 1, I get 1 or 15/15. I avoided plugging in the -1. I've got 3 minus 10 is -7 plus 15 is 8 times 2 is 16/15. No calculator even. You do get a calculator on this test, but without a doubt, they would ask you to do that. No calculator on the AP exam. That's the hard part, is that you really can't. It's very, very challenging to figure out how to check your answer. You can check the integral, but you can't check to make sure that the integral is set up right to begin with. And that's what's difficult. Okay. Find the area bounded between the curves y equals 2x minus 2 and x equals y squared minus y. Okay, so Rowan, please state what you notice about this problem compared to the others that we've done. It's x equals instead of y equals. And you remember last year when we talked about conic sections that we had 2 different types of equations for parabolas. We had y equals, we had that a times x minus h quantity squared plus k, but then we also had x equals a times y minus k quantity squared plus h. Remember we talked about, for example, like the focus and the latus rectum and all those pieces? And I said rectum, you guys all laughed. Yep. Okay. So, right. So we get all these pieces, but we realize that, this parabola right here went up and down, whereas this one went, side to side, right? So this parabola goes side to side. I think one of the best things for me to do is just get a general idea of what the heck this even looks like from the beginning. Would you agree that this factors to x equals y times y minus 1? So usually when we factor it, we identify the x-intercepts. Well, these are going to serve as the y-intercepts. So it's going to cross the y-axis at 0 and at 1. So I'm going to start by sketching a graph. I'm going to cross at 0 and at 1. Anybody know if this is going to open up to the right or open up to the left? Why does it open up to the right? This is positive. See, all these things are coming back to you because you had an awesome teacher. No, but when I figure it out, I'll let you know. Yeah. Then we have another equation, and you guys know what this looks like. What is it? Is everybody okay? Because the first step is always that you would be able to um, see the area that you're working with. Can everybody see the area that they're working with? Now that we've identified the area that we're working with, let us look at the challenge that we face. We draw a vertical rectangle to say top minus bottom. What's on the top, the parabola or the line? But if I draw the rectangle here, why is that problematic? Because it's a parabola on top and the same parabola on bottom. And so if you do top minus bottom, they would just cancel, wouldn't they? So therefore, you can't draw vertical rectangles. Instead, what I do is I draw horizontal rectangles. And wherever you draw the horizontal rectangle, what's on the right side, the line or the parabola? The line. And the parabola is on the left-hand side. So instead of top minus bottom, we do right minus left. Right minus left. Notice this rectangle, the thickness goes up and down, right? As opposed to side to side. So instead of dx, we call it dy. Once you identify that the thickness of the rectangle is dy, that tells you that everything must be in terms of y. Everything in the integral must be represented with y. So let's look and see what we have. You have the right minus the left. And I know that the left is going to be y squared minus y. But the right side is 2x minus 2. That's a problem for me because it's not in terms of y. Okay, so Katie does this correctly. She says y is equal to 2x minus 2. She adds the 2. Y plus 2 is equal to 2x. And she divides by 2. You get 1/2 y plus 1 is equal to x. So she simply solves for the line in terms of y. We good? So now I have 1/2 y plus 1 minus y squared minus y. I'm going to integrate that because I don't want one rectangle. I want an infinite number of rectangles. In calculus, we say no big deal. Just so, do you see this? If I add 2 and divide by 2. All right, I now need to figure out my bounds of integration. In order to figure out my bounds of integration, I need to be able to identify the intersection points. The intersection points are not given to me in this scenario. So, anybody want to take a shot at how we would find the intersection points? Okay, we could do that. We could take this guy right here instead of equal to that guy right there. Like here, this is y equals and that's x equals, so it wouldn't work very well here, would it? You could use substitution. Like this is y equals, so you could take this and plug it in for, you know, y, right? Or you could do the opposite. You could take this and plug it in for x. You know, you want to do that? Okay. So if we do that, then we get y is equal to 2 times y squared minus y minus 2. So are we okay there? All right. So we have y is equal to 2y squared minus 2y minus 2. Now what? Subtract the y. So 0 equals 2y squared minus 3y minus 2. Do you think that factors? 2y and y. Try a minus 2 there and a plus 1 here. do you think about that? Does that work? So what are my y values for my solution? Maybe 1/2 and 2. So look at what that means, folks. That means that my y value here is positive 2, and my y value here is negative 1/2. Does it look like that kind of matches up with my drawing? Yeah, it sure does. So you know, if you want to figure out your x values, that's fine, but we don't really need them. We just need the y values of our bounds of integration. That's it. So we go negative 1/2, and we go 2. Would you like to combine the 1/2 y and the minus negative y? Okay. All right, so we'll write it out again. We got negative 1/2 to 2 of, we're going to have a negative y squared, 1/2 y minus negative y, 3/2 y. So plus 3/2 y, and I have a plus 1 dy. Antiderivative of negative y squared. Cool. Plus antiderivative of 3/2 y. Very good. Plus y. Bounded negative 1/2 to 2. Looks like 4 is going to be my common denominator here. Need to get myself set up because I know this is going to be an issue. Okay, plug in the 2. Common denominator not of 4, but it looks like of 12, right? I have to do 12. So plug in 2, what do you get? Negative 8 over 3. So negative 32 over 12. All right. I need you guys' help here because we could definitely make a mistake pretty easily, okay? I plug in 2. 2 squared is 4. So 36 twelves. We good? All right, now I'm going to go to the negative 1/2. Oh, I really don't like this, but oh well. What is negative 1/2 to the third? Negative 1/8. And then make it negative, so it's positive 1/8. What's 1/8 divided by 3? 1/24. That's all right. We're tough. We'll do it. Then I do the negative 1/2. Negative 1/2 squared. 1/4 times 3 is 3/4 divided by 4. 3/16. And then we do minus 1/2. Yeah, so let's just grab our calculator. We could do it, but... So we go negative 32 over 12 plus 36 over 12 plus 24 over 12, parentheses minus parentheses 1 divided by 24 plus 3 divided by 16 minus 1 divided by 2. And I hit that math button, convert to fraction, and it gives me 125 over 48. It is amazing. Your calculator is capable of actually even more than that. I showed you last year, you guys had the same reaction. You're like, what? Nobody ever showed us this before. Okay, I need you guys to just pause for a second, look at the problem. Folks, look at what you did. When did you learn how to graph a line? 7th grade. When did you learn how to graph sideways parabolas? Last year. When did you learn how to find the intersection of two curves? Algebra 2? Algebra 2. When did you learn how to factor? 8th grade, ninth grade? So look at all the skills that you've used over your lifetime to come up with this type of problem. It really is a culmination of many of the pieces that you've done. It's an impressive piece. It really is. I think it's really awesome. So, okay. Last problem. Straight from the AP exam. Second most common type of question asked from the AP exam is one of these kind of problems. The most common one is the motion of a particle. Yep. Okay. And we are only going to start with the very first one. Now, I want to be clear. This is question 1. This is calculator allowed. And it's when we look at these problems that we say, how could anybody not get at least a 3 out of 9 on the math portion or on the free response portion for this type of problem? Because right now, every single one of you will know exactly how to do A. You'll know exactly how to do it. And you look at me like I'm an idiot, but trust me, you'll know how to do it. It says, let f and g, and we're only going to do A. That's all we're going to do right now. Let f and g be the functions given by f of x is 1 plus sine of 2x, and g of x is e to the x squared. Let R be the shaded region of the first quadrant enclosed by the graphs f and g shown in the figure above. It tells you what g of x is, doesn't it? It tells you what f of x is, doesn't it? Look at the first question. Find the area of R. So if you want to find the area, what do? F of x minus g of x. Everybody agree I do top minus bottom? So letter A, integral f of x minus g of x dx. On the actual AP scoring guidelines, they do put parentheses around that so that everything has dx. I will not do that. I don't know. I don't believe that they would actually mark that wrong. I'm going to try to reach out to some people on the College Board and ask about that grading piece. What am I missing? I'm missing my bounds. Can somebody tell me, how would you find your bounds of integration? Plug it into a calculator. Let's notice the first bound, though. Anybody want to guess what this bound is right here? Probably. Let's confirm that this point right here, that it happens at 0. If we plug in 0, we should get the same thing. What's the sine of 0? Plus 1. And what is e to the 0? 1. Does everybody agree that that coordinate right there is, in fact, 0, 1? Okay? So 0 is our first spot. So we only have to find that second spot, don't we? So take your calculator and go y equals. And type in for f of x, 1 plus sine of 2x. And make sure that you weren't teaching a college trig class and you dump back into degrees. That would be a bad thing. So we're sitting in radians, y equals, I got 1 plus the sine of 2x. And then down below that, I'm going to use e to the, is it x over 2? I've got my two functions. I would like to find the intersection between the two. All good with that? Second, calculate intersection, number 5. I know my calculator is in an awkward window right now, but it looks like it's not in such an awkward window that I can't see. I mean, I can see it. If you guys need to zoom in, zoom in. So first curve, enter. Second curve, enter. Guess, I don't want to guess. It's either going to find the 0 or it's going to find that spot over there. It found it right here. So here's what I like to do. I like to call that A is equal to 1.135695. So anybody want to guess what I put for the top bound here? A. I've identified in the problem that A is 1.1356925. So they'll continue to use that the whole way through. You just make the note once. That's all you have to write. You don't have to write the 1 plus sine of 2x. You don't have to write the e to the x over 2. You can use substitution all the time. Now I have to evaluate it. Do we know how to do that? Yeah. You don't have to do it by hand. You just use your calculator. Y equals. Hey, I don't want that function, do I? So let's take that function off. Let's take that function off. And let's put a new one here. What should I put? Or how about I do y1 minus y2? You guys good with that? If you want to write in everything, that's fine. But I just notice I make less mistakes in. I go into vars, y vars, I grab y1. Minus vars, y vars, grab y2. That's the only one I'm looking at now, isn't it? So I'll go to normal viewing window. So apparently that's what it looks like. Super cool. And I'm going to calculate number 7. What's my lower limit? What's my upper limit? .429. Does everybody agree that everybody can get that? Like you know how to do intersection, right? You know how to do y1 minus y2. That's 3 out of 9. 3 out of 9 right there on the AP exam without doing any of the other 2 problems. That's 3 out of 9. Totally doable. All right. Rest of the time is yours.